Thank you very much, everybody, for attending what is our final online technical evening of 2021. Hopefully, it's possibly our last online technical evening, and hopefully we'll all face-to-face in October later on in the year. Although it's maybe something that I'm looking into now that we could do both. Tonight's technical meeting, we'll get on to that now, is by Metso Outotec, and who kindly represented us here tonight. There's Adam Moore and Pierrick Boulay, who will be giving us a presentation on new developments on cone crusher technology. I've seen a wee bit of a highlight of it there already. So without further ado, I'd like to pass you on to Adam Moore of Metso to start tonight's presentation and give you an insight of what's going to be happening for the presentation. Thanks. Okay, Adam.
Good evening, gentlemen. Thanks, John, for the introduction and the opportunity to meet and present to you some technical aspects of our recent developments in cone crushers. Not an easy subject to change. It's evolved for us, and we've managed to secure Pierrick Boulay, who is our MX, is our new generation of cone crushers being developed currently. And Pierrick joined the company in 2006 in the design department, in the HP crusher design department. So he's seen a few years in the design disciplines, and in 2019 he was appointed global product manager for the new MX cone crusher range. So we're here tonight not to give a sales pitch, but to give the background of what we think is the pedigree, is the developments, which we hope will demonstrate advantages in the operations eventually. And I don't think I'm going to labour the point any further and ask Pierrick to start his presentation.
Okay, thanks, Adam, for the introduction. So today I am going to show you what is our MX multi-action cone crusher. So first part of this presentation is focused on the benefit of the MX technology to improve your profitability. Then we will go more in detail with the design itself to finish with the performance that we can achieve with this technology. And I think that at the end of the presentation, we will have a Q&A session. Prior to go through the MX, on this slide, you can see our product portfolio. And I am sure that you already know our best sellers such as HP crushers or C-Jaws. And we are now launching 2 new products with MX, but also HRC to extend the range of crushers that we have. HRC is focused on sound manufacturing, when MX is there to complete our cone crusher range with, let's say, higher performance, better efficiency, and sustainability. So this is all about innovation, and Metso Outotec is constantly trying to innovate and to push the current limits. Okay, let's start first with a video of the MX. So you can find this video on YouTube if you want to see it again. Don't worry, we'll go through the main topics during this presentation, and if you have any question at the end, we can discuss. So MX, we have currently two sizes available with the MX3 and the MX4. So they are designed for secondary, tertiary, and quaternary crushing. So in the heart of the crusher, our patented multi-action technology combines a rotating ball, like an HP, and a piston, like an hydrocone. So this delivers benefits that can't be achieved with traditional cone crusher technologies. So MX is a really new technology, and we are still learning and working to improve the design in order to have the best crusher at the end in every aspect, such as performance, reliability, and maintenance. So in the future, we will have a wide range from 200 to 600 horsepower crushers. So let's have a look on factors impacting on profitability in a quarry. So what determines the total production of a plant is the capacity and the uptime of the process. A good capacity is important, but if you have to stop the crusher to adjust it, then you will lose some production. Then the revenue of a quarry is determined by the production of the average sales price and of the produced product. So how you can impact on the value of your product is by maximizing the production of those fractions that have, let's say, highest demand and highest price in the market. And then finally, you get the profit of a quarry by reducing the operating cost from the revenue. So basically, you get there are three key variables that you want to impact on. So process uptime, value of your product, and OPEX. And this is what we are improving with MX. So let me show you. Let's start first with the uptime. So with the multi-action technology, you can increase your crusher uptime by up to 10%. So first, thanks to the piston, you can do setting adjustment under load. So no need to stop the crusher or the feed to adjust the setting. In addition, our IC automation does dynamic wear compensation while crushing, meaning that a true crusher setting remains constant even when liners wear, and it allows the customer to keep the production constant. If the setting is constant, then the production is constant. So for this, no need to stop the crusher. It's automatically done by the automation while you are crushing. And finally, one major benefit of MX is also fast liner change in just few hours. So thanks to the rotating ball, we have access to the wear part and there is no backing used. So this is for the uptime. So now that we have seen how to improve the uptime, let's have a look to the selective production. So to improve value of your production, you want to maximize the yield of the most desired fraction. So this is what we call the selective crushing. In MX, we have 6 adjustable parameters that can be used to optimize the crusher performance. And compared to some other products, for example, compared to HP, we have noticed that all the parameters can have a big impact on the production. So you can really optimize or change the production. Of course, you can change the speed of the crusher to increase or limit the production of fine, for example. The setting that is constant and adjusted under load has a big impact. We have different eccentricity and some option, some eccentricity are under development to change the capacity and the production. Cavity density on MX, it has a big impact on the product gradation and can be monitored by the feed level above the choke feed and our automation. So more density, then you will produce more fine, and less you can limit the production of fine and maximize the levels. Cavity type. So with MX, we deliver the crusher. We have 5 options. So for some manufacturing with extra fine, for example, then we have fine and medium cavity. And for secondary crushing, we have coarse and extra coarse cavity profiles that are available. And the last one is the crushing force that we can measure and adjust with the piston. So here we see one example of selective crushing with an MX4. So in this case, the customer wanted to maximize the production of 420 fraction. So initial setup was with higher speed, higher piston pressure, as well as high material feed level. So to optimize the production of 420 fraction, crusher speed and material feed level were decreased, also reducing the piston pressure. And as a result, production of 420 slightly increased, but more importantly, it generated a lot less 0.4 fraction, which was considered as waste and non-wanted product in this process. In addition, as a result of producing less waste, energy consumption dropped significantly with about 22% saving compared to the first setup. So with this case, we see that we can really have an impact on the production with the MX. Okay, operating cost now. Crushing represents typically from 20 to 30% of the total cost in a quarry. So out of this, energy and wear parts costs are the most significant cost factors. So how you design crusher cavity is a key in managing wear part lifetime and energy efficiency. In MX, crushing force is well distributed in the cavity, and there is a lot of rock and roll crushing action, so reducing the wear. But in addition, we know that rock and roll crushing is a key in generating good end product shape. Stroke direction in MX is perpendicular to material flow, improving the manganese work hardening and also generating less grinding effects, so less wear. Multi-action technology allows long vertical travel of the ball and the head, which has allowed us to design thicker liners and thus increasing the wear part lifetime. All these contribute to have a longer wear part lifetime compared to traditional technology. But in addition, we have seen with the previous slide that we can have a significant impact, a significant saving with energy consumption and to decrease and reduce the operating costs. So to summarize this first part, this is how you can improve your plant profitability with MX. So we can have an impact, we can impact the 3 main variables driving profitability in our process: uptime, operating cost, and the value of the product. And in addition, MX is, let's say, safe and simple. Safe as we have a relief valve and low oil volume below the piston for a quick reaction in case of issue, in case of Trump event. And simple as the automation enables to monitor the crusher easily and automatically. So now that we have reviewed the main benefit with MX, let's move now on some design details. Let's start with the piston. How does it work? Every day, you start the crusher with the piston located at what we call the home position. So this means that we always keep a stroke above the piston for automatic wear compensation and setting adjustment under load during the day. In addition, we have a constant trump release and cavity clearance room space below the piston. So as main benefit of the piston, we have adjustment, as I already said, under load, and the same protection regardless the liner wear, as we always have space below the piston. The rotating ball now. So at the end of the day, let's imagine that the wear compensation was 10 millimeters during the day. Okay, let's try with one example. So on the morning, the piston is at its home position, and the ball position, in this case, is at 100. During the day, due to the wear, let's imagine that we have to compensate 10 millimeters with the piston during the day. Then at the end of the day, when you stop your crusher, when you stop the MX, the piston will go back to the home position. So basically 10 millimeters lower. And in addition, the ball will rotate to compensate the wear up to position 90. So from 100 to 90. So in result, the day after, when the crusher will restart, you will keep the same setting than previously. And this is done automatically when the crusher stops, so it is transparent. As main benefit to have a rotating ball, such as HP, we have an easy access to liner to do fast maintenance. Thanks to the rotating ball, wear due to feed segregation evenly spread. So this allows to keep a constant CSS compared to, let's say, what we call the fixed cavity design. You know, due to the segregation, if you have more fine on one side than the other side, so when the ball liner is fixed, you can have more wear on one side. So the setting is not constant and the position is not constant. So on MX, thanks to the rotating ball, like an HP, you don't have it. In addition, with MX, we have a true head anti-spin feature to stop the head rotation. So composed with a freewheel to prevent the rotation in the counterclockwise direction and a clutch. So this allows the head to rotate while we are crushing, but it stops the rotation in idling. So this is important, and as main benefit, this is good for on-off feed condition when you start and stop the feed very often during the day, and for sound manufacturing, and it improves the liner lifetime. So to summarize, with the MX, we have a lot of benefits. So no backing on liners, no bouncing on thread. The adjustment ring is fixed to the mainframe, compared to an HP, for example. We don't have any accumulators, so we just have a relief valve to protect the crusher. So the MX is a compact crusher with low static and dynamic stress. So it allows to have lighter structures, and this is perfect for mobile units. Head is not spinning in idling. We can adjust the setting under load for more uptime. We have a high stroke and a big reduction ratio. we have a big cavity clearance, whatever the liner wear is. The wear evenly spread for a constant setting, as I said, thanks to the rotating ball. And we have a constant trump release regardless liner wear, as the piston never starts from 0, but always from a home position with a stroke to protect the crusher. And finally, we can do, as we said, maintenance really fast with MX. Some words about our automation now. So we deliver the MX always. It's not an option. As a complete package with our automation that allows to monitor all parameters, such as, of course, setting, power, pressure, but as well feed level. We can operate different modes. Setting mode, pretty standard, with a setting as target, or load mode, with power or pressure range target. So whatever the abrasiveness is, the crusher will automatically readjust the setting to be on power and pressure target to keep the production constant. We can, as you can see on the bottom pictures, we can control the cavity level with a set point, and the automation will adjust the feeder speed automatically to keep the level constant. So as already said, we can do automatic wear compensation. So the automation will calculate the kilowatt consumed, and according to the abrasiveness and to the application, we know that 1 millimeter wear means, let's say, 200 kilowatts. 200 kilowatts, let's say that. Then the automation will know that and adjust the CSS and correct the CSS on the load. We have, this is important, we have access to all the events and alarms of the crusher for some days and months. And we can do fast analysis with the logs files that we can collect from the display. We just have to plug a USB stick on the display, and then we collect all the information from all the sensors. So we have one data every 2 seconds for every sensor, so temperature, pressure, power, and so on. And the remote user interface is easy to install with just a computer and a connection. And then you duplicate the screen on the computer, the screen that you have on the display close to the crusher, and you can do everything except the maintenance operation, where we don't allow to do that from the remote user interface, because it's important to be close to the crusher to check that everything is okay when you do maintenance. Next, so some words about our VisioRock now. So we propose our VisioRock to optimize the yield of the desired fraction. So this is a camera system analyzing the production during the day. So today we can see a deviation in the production and adjust the setting if needed. So this is the beginning, really only the beginning. It just shows today the field analysis and the deviation. However, our ambition for the future is to be able, with the VisioRock, to automatically adjust the crusher parameters, such as the speed, the cavity level, and the setting. So the parameters that have a big impact on the production. So to maximize the yield of the desired fraction, for example. So we can imagine in the future that the customer could select on the morning the fraction he needs, the fraction it needs to produce. And the crusher could adjust different parameters autonomously to maximize the desired yield. So it's more the future. Today, to be honest, it doesn't do that. We see the deviation. We have a graph and we can see the deviation and adjust manually the setting to be back on the production needed. But we in the future, this is what we want to reach. So this was for the technical review. I will now share with you the data we have collected from field regarding MX performance. Just few examples. We have plenty of those. So let's start with some secondary application for you to have an idea of the production. First, an MX4 in secondary to produce railway ballast. So MX is getting 40 to 160 millimeter feed. Material is really hard with crushability index at 25% and very abrasive in this case. And here you can see the feed and product curves. And in this case, we are able to reach 35% in average of ballast with a total throughput at 480 tons per hour. And still with an excellent shape and quality of the end product. Second example in secondary with an MX3 now. And again, with great results and way better than the crusher that was replaced. A pretty similar result than the MX4 before. So here, in average, we are producing 31% of ballast and up to 40% according to the feed variation that the customer is having. And total throughput in this case on the MX3 so was 420 tons per hour. So in secondary application, we have really good results, excellent shape, an excellent yield of the end product. So let's have a look to one tertiary case now with an MX3 replacing an HP 300. So we replace the HP 300 by an MX3. So the customer on this application wanted to limit the production of dust, so considered as waste on this application, and to maximize the production of gravel and mainly the 6 to 10 millimeter fraction. So here you can see the results. So in green is the MX3 and it's gray, in gray is the HP 300. So feed size on this application was from 10 to 50 millimeter. Material is hard. Crushability index was at 25%. So on this side, you can see the production, the product gradation for MX3 and HP 300. Top left corner in a percentage and bottom left corner in tons per hour. And if we look the amount of 0.2 fraction, we see a significant drop of production compared to HP. So from about 15 in average to 12.5 for the MX3. So a good improvement. And again, the customer really want to limit the production of 0.2 fraction as it is considered as waste for this customer. So what the customer is targeting is to maximize the 6 to 10 fraction. And there we see a significant increase on the production. So from 30 to 37 tons per hour produced. So what is huge. We were able to reach those performance because in order to reach the quality on this application with the HP300. For example, we were running the HP300 at the maximum speed, so 1180 rotation per minute, because with lower speed the quality was not good enough. On the MX, the quality was good, so we were able to decrease the speed to limit the production of sand and to maximize the production of gravel. So this is why it was possible in this case. With the same speed, we have an improvement, but of course not 24% more gravel like we can see on this picture. So not only we were able to increase 6 to 10 production, but also the quality of the end product. As I said, even with lower speeds, the quality was still better with the MX3 than the HP300. So on this graph, top right corner, you can see product shape measured with flakiness index, so small value indicating better shape. So as you can see, the quality of the product is excellent in all fraction and better than what we were producing before. And finally, let's have a look to one case in sand manufacturing. In this case, no problem to run an MX3, even if with this really tough application. Crushability index at 21% and very fine feed material, smaller feed than the CSS, but not a problem. So we were able to produce up to 50% of 0.5 fraction and still with excellent shape and quality of the end product. Compared to the crusher before, that was a VSI, and VSI are really known for the quality. So we were able to do the same, at least with the MX3. And the customer that has replaced the VSI was able to double the production with the MX compared to the VSI, because of course on VSI the capacity is not and the reduction ratio is not big. So whatever the application is, we have noticed very good performance with MX, thanks to the cavity design and the technology. So that's all. To wrap up with MX, we want to help customers to improve their performance and profitability. So we try to impact on 3 factors: value of sellable product, operating cost, and uptime. And we have seen during this presentation that MX is designed to address it. This is a really new technology. We are still learning. We are still improving the concept every month to get at the end the best crusher. Anyway, we are confident that to get this new technology proven and a reference in the coming years. And that's all. So thank you all for your attention. So do you have any question or details that you want to review?
Pierrick, it's Stephen Robinson of Robinson Quarries here in Northern Ireland. You mentioned one of the parameters that you use for changing your product quality is changing the speed. Do you do that by inverter on the motor, or do you change the motor pulley or the crusher pulley?
Crusher pulley, but in some application, customers are having VFD. Today, it's not automatic with the automation, even with a VFD to adjust the speed. It will be more in the future when we will have the VisioRock, for instance. But today, it's let's say the standard package is with pulley. But in secondary, we have several units with VFD to be able to adjust a bit the CSS. But it's not automatic.
Thank you.
Eric, I have one via the chat from Wayne van Antwerp. He asks, what is the stroke clearance from the home position?
So let's get the MX4 as example, the home position of the MX4 is 70 millimeter. So we have always 70 millimeter below the piston to move the head down and clear the cavity. So 70 millimeter doesn't represent 70 millimeter as CSS. It's a bit less, so about 40. You can increase the CSS by moving the head down by about 40 millimeters when you are at home position. A bit more at the end of the day when you have compensated the wear. So let's say about 40 millimeter setting in addition to the CSS.
Okay, in response to that, thanks, Pierrick. He's asked, so a 40 mil block would be the limit?
40 plus the CSS. So it depends on the CSS that you are having. So it's in addition to the CSS. So if the current CSS is 20, I would say that it is 60. So if it's in secondary, of course, the CSS is even larger, so it will be even more. We have made a lot of tests on MX, really a lot of tests with Trump event, with metallic part through the cavity, and we never reach the piston zero position. In general, we have to use only half of the stroke. For the travel, as the piston react very fast. We don't have the piston doesn't have a big diameter, so not so much oil volume. So, and with the wheelie valve, we can really open the CSS very fast.
Pierrick, are you looking now, the HP design is 20 years old, are you looking to replace that eventually with the MX series?
So it is our ambition for the future. So we will do streamlining for sure. Not all the HPs, because in some, we will have, let's say, more MX for really premium performance, and we will still keep continue to get some HP, but not the full range like we are having today with HP 100 and HP X in the future. So we will do streamlining. MX will be in addition, but we will do streamlining anyway. And our ambition is to get on our mobile application, on our local track, only MX in the future.
For instance, at the moment you have HP 300, for example, and then you have HP 3, and then you have MXX now. So that'll take over some of those ranges.
So today you are right. We have HP 300, HP 3, and MX3 in the same, let's say, size or category. And in the future, we'll have only 2 of those. So MX and 1 HP. And I cannot tell you today exactly which one will disappear. It will depend really on the performance we are achieving, but most probably we will keep HP 100 and MX in the future according to the results. But first we have to get the MX proven, the MX technology proven. As I said, we are still having some challenges. We are addressing the solution. It's really a new technology. We are still learning, and with HP we are still learning either and doing some improvement every year. So it will take still some time, but yes, in the future we will have only 1 range of HP and 1 of MX and less GP.
Thank you for that. Thank you.
Eric, are these machines going to be, maybe you said that already, but are they going to be going on to the mobile equipment as well?
Yeah. Yeah, we have 4 prototypes with the MX3, and the performance are really, really excellent. Way better than what we can achieve with the GP220, for example, if we compare with the MX3 with the same size. And we are even having some issue to feed enough the crusher. So that's why also we develop some additional stroke, as I said, additional eccentricity, as I said on the presentation, is to be able to adjust the capacity. But yes, in the future, so we have 4 prototypes during this year that are running, and at the end of the year, if everything is okay, or we will do maybe some adjustment. Next year, we will continue to launch with the launch with the LT3MX.
I have another question via the chat, again from Wayne. He apologises his mic's not working. Why does the MX not have a separate counter shaft box? I see the box is part of the mainframe.
Okay, good question. Good question. MX, I would say we have today also one prototype, the MX6, with one prototype, and on the MX6 we have a counter shaft box, but not on the smaller crushers. So it's not MX is not having a counter shaft box. It depends on the size and the application where we will be. For example, in mining, it's more heavy duty. So, and for bigger crusher, it's more difficult to repair the mainframe in case of issue, for example. So for bigger crushers, we will have a counter shaft box. So certainly MX5 and MX6 and MX2, 3, 4, when they will be ready, will not have a counter shaft box. So it depends on the size. And for example, HP3 doesn't have a counter shaft box. HP4 doesn't have. HP 200 or 300, only one is having a counter shaft box. I don't remember which one, but it's not on all HP that we are having a counter shaft box. It depends on the size as well. HP 400 and HP 500 are having a counter shaft box. So we will follow the same logic. Bigger crusher will have it, but not the smaller crushers.
Okay, Pierrick, from that answer, he's asked, does that make it more difficult in fitting shaft, pinion and bushings?
No, I would not say that. We don't have problem with HPs. It's exactly the same technologies, except that the pinion gear, it's a spiral pinion gear on GP, so more compact parts. But no, it's not really difficult to install it compared to a counter shaft box. It's more, we are having counter shaft box on a crusher. On some crusher, it's more according to the size. If we get an issue with the bushing, to be able to replace, to repair easily on bigger sizes, because it's more, let's say, it's more critical on bigger sizes. But for small sizes, it's not a problem today on HP, and it won't be a problem on MX.
Thank you, Pierrick.
Any other questions for Pierrick? No, well, if there's no other questions, thank you very much, Pierrick. That was a very in-depth presentation. I found it very interesting, especially about the speed aspect of the machine. I was going to ask the same question as Stephen. It's something we've looked into ourselves, putting inverters on the crushers, but obviously it's still in the work program for you guys as well. The other thing was quite interesting. You're saying that it's nearly a direct replacement for a VSI, which seems unbelievable that a cone crusher can do the same tonnage of sand as what a VSI can do. But very, very interesting. So I would like to ask Pat O'Connor if he would mind doing a vote of thanks tonight on behalf of the members.
Great presentation, very in depth, an awful lot to take on, but to take on board, especially I wrote down about the profitability and the energy savings and the less operating costs. It means a lot to everybody too. It was a great presentation. I'll be speaking to that more later on in the week, hopefully, because we're going to put a new cone crusher in the next few weeks, hopefully. So, and especially when I seen the video starting off, I thought it was two spaceships going to land or something like that there, or the lights and stuff like that there. Yeah. Also, I suppose long gone is the time when we used to put the wire rope round the crushers and attach it to a machine for to open them and close them and different things like that. There, this new technology has done away with all that. There, probably Stephen Robinson, the only one would maybe remember that there, but I get into trouble for saying that, but there you go. But Pierrick, just want to thank you very much on behalf of the Institute for your great presentation tonight. It was very interesting. So I would ask the members in the usual way to show their appreciation. Thank you, Pierrick.
Thank you. Thanks a lot. Thanks for the opportunity. Bye-bye.
Thank you, Pierrick. Thank you.
Thank you. Right. Good night. Good night.
Thank you.
Good night.